Good afternoon, everyone. My name is Guo Xiaoxian. My group member is Gao Jingyi and Wu Fan. Today, we will introduce a new material which is called wood sponge. With the discharge of a large amount of oily sewage in production and life, and the frequent occurrence of oil leakage accidents at sea, oil pollution in water has become a major problem that endangers human health and environmental safety. Herein, scientists report an effective strategy to create anisotropic cellulose-based wood sponges with a special spring-like lamellar structure directly from natural balsa wood. The synthesis of wood sponge is divided into two parts. One is preparation of wood sponges, and the other is cellulation of wood sponges. The synthesis process is shown in Figure 1. First, choose a 15 x 15 x 10 cubic millimeter balsa wood with a density of 92 milligrams per cubic millimeter and over-dried at 18 degrees Celsius for 12 hours before use. Then selectively remove lignin and hemicellulose while chemical treatment to break the thin cell walls of natural wood, which lead to a lamellar structure with a wave-like staked layer upon freeze drying. Finally, in order to obtain hydrophobic properties of material, vapor deposition is used to deposit a polysiloxane coating on the surface of the wood sponge cellulose skeleton to give the material good hydrophobic properties and retain its original pore structure. The resulting cellulated wood sponge exhibited high mechanical compressibility and elastic recovery. The wood sponge showed excellent oil or water absorption selectivity with a high oil absorption capacity of 41 per gram. Moreover, the absorbed oil can be recovered by a simple mechanical squeezing, and the porous sponge maintain a high oil absorption capacity upon multiple squeezing absorption cycles, displaying an excellent recyclability. This is all my part. Thank you. Let me turn to Jingyi.
Thanks, Xiaoxian. Now I will show the specific structure of the wood material. We can see this 9x9 photos. It shows the differences of the three stages of the development of the wood material. We can see the first row in the figure. It shows the natural wood, the SEM image of the detailed structure. With the development of the material improvement, we have the lignified wood, as it shows in the second row. The structure is similar to the honeycomb structure, but it shows more layers. To further optimize the structure, an additional chemical treatment with the NaOH solution was used to remove the residual hemicellulose in the liquefied wood. After removing the lignin and the hemicellulose, the original honeycomb-like structure disappeared completely and evolved into a spring-like lamellar structure with numerous wave-like stack layers. This special spring-like lamellar structure was expected to contribute to the higher mechanical flexibility. Also, another specific thing of the wood sponge is continuous oil separation. The wood sponge exhibits anisotropic liquid transportation properties. However, it along the channel direction has a much higher transport speed. An oil collection device was designed by taking advantage of the unidirectional liquid transport of SWS, which was used as a filter to realize the continuous separation of the oil from the water surface. This result suggests that the oil collection device based on the modified wood sponge can be used to continuously separate the component from the water. In this way, oil water separation and oil collection can be achieved simultaneously, thus saving the complex and time-consuming process of the oil recovery from the absorbent. This oil collecting device allows in situ collection of the contaminants from the water surface effectively, which can be used as a portable equipment for dealing with oil or organic solvent leakage. The absorbent has only been used in the semi-open seawater for the time being, and it is hoped that it can be better used in the open seawater as soon as possible. Okay, let's pass to Wufan.
Thanks, Jingyi. Now I will bring you some challenges and the recommendations of the wood sponge. Because of their amphiphilicity, this is prepared wood sponge absorb both water and the silicon oil drops, making them unsuitable for selective removal of oils from oil-water mixture. The researchers adding a cellulating agent and after cellulation, the highly porous spring-like lamellar structure of the wood sponge was well retained. The absorption capacity of our SWS was comparable or even superior to many reported absorbents, including polyurethane sponge and so on. However, it is still distinct lower than that of aerogel-based absorption aerogel-based absorbents derived from graphene and so on. But preparing these highly efficient absorbents involve either costly raw materials or complex synthetic procedures that limit their industrial applications. I recommend that the researchers still need to find a way to enhance the absorption capacity of the SWS to get the same or more absorption level comparing with the aerogel-based absorbents derived from the graphene and so on. And the other challenge is that although the wood sponge has so many advanced and specific points, most of the applications are on the oil water separation fields. We should pay more attention to some other fields. So researchers need to do some further research on whether the wood sponge can separate some other chemical substance. For example, to separate some other organic from the polar species, or maybe can use this technique to do the filtration like water treatment. And we have introduced the advanced material of wood sponge and its application on oil water separation. Since it has a wide prospect, we are all expect to see its application on the development of oil absorption in the future. Thanks for your watching.